Okay, guys, open your student journal to page 41. This is section 2.4. If you look at our goals up there, we want to be able to write the equation of a parabola in vertex form, intercept form, and standard form. So we have three ways to write a parabola. Page 41. So the first way is if we are given a point in the vertex, we're going to use this vertex form. Here's the vertex form. Y equals A. And by the way, what would A be the same as? 1 over 4P, right? So we just call it A so we don't have to write 1 over 4P every time. So Y equals A, X minus H squared plus K. This could be an X here and a Y here, but we're not going to make it that difficult in this section. We're just going to stick with the parabolas that open either up or down. The next form we have would be used if we're given a point and the x-intercepts. So the x-intercepts are where it crosses the x-axis. So if I have a parabola that looks like this, these would be the x-intercepts, and then I would be given some other point. So I'd have to plug in that x and that y value, and then the p value would be one of the x-intercepts, and q is the other x-intercept. And that would allow me to solve for A. Back up here again, if I had been given the vertex and any other point, see how I could plug in for the vertex? I could plug in for that other point, and then I'd be able to solve for A. Okay, so that's what we'll be doing. The third way is standard form. And this is if we're given 3 points, but they're not special points, they're just any 3 points. Then we may want to use the standard form. If all this gets multiplied out and simplified, here's what we would end up with. Y equals ax squared plus bx plus c. That's called standard form of a quadratic. So we have these 3 forms, vertex, hk. Plug in for x and y, solve for A. Intercept, P and Q. We're given the x-intercepts and another point, plug in, solve for A. Standard form, right here. Standard form would only be the method we use if we are given 3 points. And they're just 3 random points, nothing special. So let's look at this. Anish, did you have a question or just...
Yeah, I do. Can you graph the points to see?
Yes. I could plot these points and see, but I'm not sure if one of them is going to be a vertex, because there could be a point lower or higher. So that's the reason I wouldn't know for sure if something's a vertex, and they're definitely not intercepts, because intercepts, y would always have to be 0. So if I just have 3 random points, my only option is this. All right, so if given these 3 points, it says what is the equation of the parabola? So what I could do is this is x, this is y, this is x, this is y, x and y. I could plug in, use my first point. So using the point -1, 10, my equation would turn into 10 equals -1 squared is 1a. -1 times b would be -1b, and then plus c. That's the equation I would get if I used the point -1, 10. Then I'd have to use this point, 2, -2. What would I get then? Plug in for y, y is -2. Plug in for x, 2 squared is 4a. Plug in for x, 2b. And I don't know anything about C. Using my last point, 5, 4. I would plug in 4 for Y. I would plug in 5 for X, 5 squared, so 25A. I'd plug in 5 for X again, and I'd get this. Now, do you guys remember how in some of those problems we did earlier, we'd have 3 equations and 3 variables, so we'd have to take 2 of them and eliminate an A, another 2 eliminate an A. Remember how hard that could be on some of the problems? So This is a way that we could set it up. Like I might ask you to just set it up. But I wouldn't ask you to completely solve because it's so time consuming. So what could we do instead? You may have forgotten this. Let me show you. Here's what I could do. I could use my calculator. If I'm given 3 points, I can come up with an equation for the parabola. Everybody go under Stat, Edit. Go up to the very top and clear. Put in your points. -1, 2, 5. Put in your y's. 10, -2, and 4. Remember what we're doing here?
Oh wait, and then when you count, you just do quad.
Exactly, right. So I'm going to quit. I want to take a look at these, so I'm going to go to y equals. I'm going to turn on my stat plots. I'm going to get rid of any equations I have. And I'm going to do a zoom what? If I want to see those points I just put in. Not zoom 6, zoom 9, because I put in statistics. There are the 3 points. So there's some parabola that should go through those 3 points. That is not necessarily the vertex. Here's what I would have to do. I'd go to Stat. Now where? Calc. Which one? Quadratic, because we were told it's a parabola. Push Enter. I'm going to go ahead and tell it to store it for me. Do you remember where to go to for this if I wanted to store for me? Bars. Now where? Y bars. Function. Enter. And now I'm going to say calculate. And it tells me this would be the equation. Is it a good equation? Look at R squared. Is it a good equation? It's a perfect equation. Go ahead now and hit graph. Here's the parabola it came up with. See how it goes through those points perfectly? So that would be our quadratic regression. And we would just jot it down. It's y equals x squared minus 5x plus 4.
So you know how
So the only difference is we're doing the quadratic of best fit instead of the line of best fit. Now, on ACTs, guys, they most likely wouldn't ask you to find this. And the reason why is because not everybody out there has a graphing calculator. So they would probably say, given these 3 points, which of the following systems of equations would solve for that? Do you see how this would be the equation that would solve for that? But if we had to actually find the equation, the better way is on the calculator. Okay. All right, let's go over here now. Okay, so I hear some of you talking about the vertex on that one. Let's talk about it. See why we couldn't use that vertex form? Because the vertex is not that point. So I couldn't use that HK. In fact, if I want to find that vertex, I go to second trace calculate. What would the vertex be the same as? The minimum. So if I now go to the left, push enter, I'm going to see where that vertex is. Enter, one more time, enter. It's actually at 2.5, 2.25. So it would have been no help. If I were to use that point as the vertex, it would have been wrong. All right, on to the next page. Write an equation of the parabola in vertex form. Vertex form now, not standard. Look back at your notes. Vertex form, right there. So we're going to be using y equals a times x minus h squared plus k. All right. Hey guys, I'll help you with that as soon as we finish. Okay, go on to the next page because I don't want you to miss this. Okay, so now we're trying to find an equation of the parabola in vertex form. I have to know the vertex. The vertex gets plugged in for H and K. I must know another point, X and Y. I have to know all of that in order to be able to solve for this A value, which is 1 over 4p. We're going to do the first problem. Is this point a vertex? Yeah, this is a vertex. Therefore, this is H and this is K. This is just some random point, X and Y. We'll go ahead and use it. So watch what we're going to do. We're going to do it over here in this space since we have it. I'm going to plug in Y. I don't know A. I'm going to plug in X minus, I'm going to plug in H. We're going to square it. And then we have to do plus K. But K is -2. Questions on where those numbers came from?
Where did the 6 come from?
The 6 came from Y. See how this is X, Y? So I plugged in 6 for Y. All right, so now I have to solve this. So I'm going to have 6 equals 4 minus 2 is 2, squared is 4. So that's 4A minus 2. So now I'm going to add 2 to both sides. And so A is going to be 2. When I go back now to write my equation in vertex form, I don't substitute in for Y now, because in order to have an equation, I have to have X and Y just written as X and Y. So my equation is going to be Y equals, plug in for A, don't plug in for X. Do we plug in for H and K to get into vertex form? Yes. So I have minus H squared plus K. And that would be the equation. You don't have to do this, but I just want to show you something real quick. I'm now going to check this. I'm taking the test and I finished early, and I'm allowed to use my calculator. Watch what I do. I put in the equation. I have to turn off my stat plots. That's going to cause me issues if I don't. I'm going to do a zoom 6. I'm going to look at that parabola. If I've done it correctly, it should look like that. Now I'm going to look at my table of values. What points should I see? These two, right? Look, 2, -2, 4, 6. So now I know that equation that I came up with is the correct equation. Okay? All right. We don't have time to do all of these. We may come back to one if we have time, but let's go down here. Write an equation of the parabola in intercept form. Look back at intercept form. Intercept form. Y equals A times X minus P times X minus Q. Jot it down.
Are we going to add the formulas?
No.
Just memorize it.
Yep. They're in boxes, so you just know that you're going to have to memorize those 3. And you are going to have to know how to find the focus and the directrix too. Tomorrow I'll write all the stuff down that you need, okay? Okay, so we have to figure out what A is. Again, that's our whole goal. We need to know A. So what am I going to have to substitute in for? X and Y, and also P and Q. So I'm going to have to substitute in here, 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 everywhere except for A. That's the only way I can find A. All right, so let's do this first one here. Actually, let's go down and do this one. Can you see here that these are what the intercepts look like, though? The intercepts are when Y is 0, it's what X is. So here, an x-intercept is -4, an x-intercept is 6. So let's go down and look at this one now. So one of my x-intercepts is -5. So this is going to be what I call P, and this is going to be what I call Q, because those are intercepts. P and Q are the intercepts. What's this one? Is that X or Y? 1 is what, guys? X. 84 is Y. Plug everything in. What do I plug in for Y? Do I know A? Nope, that's what I'm looking for. What do I put in for X? 1 minus negative 5. Well, that's plus 5. Once again, X is 1 minus 8. All right, so let's solve this now. 84 equals, that's 6, that's negative 7. So what's 6 times negative 7? Negative 42A. And so what's A going to be? Negative 2. So now I have to rewrite the equation. So it's going to be Y equals, A is negative 2 times X minus negative 5 would be plus 5, and X minus Q. And there it is in intercept form. Intercept form, right? See how these are my x-intercepts? I can see my x-intercepts immediately. Any questions? All right, so those are the 3 forms we're talking about. Switching gears just a little bit now. In exercises 9 through 11, analyze the differences in the outputs to determine whether the data are linear, quadratic, or neither. If linear or quadratic, write an equation that fits the data. I actually want to start with this one first. So I want you to look at this. Are the x's increasing at a certain rate, a constant rate? So now I'm going to look at the y's. To go from 36 to 30, that's negative 6. 30 to 24, that's down 6. 24 to 18, that's down 6. That's down 6. That's down 6. So were those first differences all the same? Yes. When the first differences are equal, that means that we have a linear function, right? You should already know that. Watch how quickly I can come up with this linear function. It would be y equals negative 2x plus 36. I want you to think about that for a minute. How did I get that? Okay, Anish thinks he knows. I need to see a couple more people. I've got a couple more. Anybody else think? Okay, I've got 4, 5, 6. Okay, let's go with you, Ryan. What do you think?
So x increases by 3 units each time. So negative 6 divided by 3, which is low, which is negative 2. And you add your y-intercept, which is 36, so you get 0.036.
Right. All I did was I used y equals mx plus b, right? They gave me the y-intercept. The slope is going to be the difference in the y's over the difference in the x's. Okay, everybody got it now? Okay, so that would be an example of a linear function. There is no reason to put this into your calculator and do a linear regression on it. Do you see why some people might think that would be the way to go? But that's too time consuming. All right, now let's go back up to this one. So I'm going to look at my first differences. This is down 8. This is down 40. Down 72, down 104, down 136. Is this linear? No. Okay, I'm going to check my second differences. This is down 32. This is down 32. That's down 32, and that's down 32. So what's that? What do you think that means when those second differences are equal? Yep, then it's going to be quadratic. It's going to be an x squared. What do you think it would be if the third differences were equal? Somebody whispered it. This is x to the first, x to the second. This is x to the third, which is cubic. We're not going to do that yet, but that would be cubic. All right, so anytime we have that happen. Now, if the first differences aren't the same, and the second differences aren't the same, and the third differences aren't the same, it may not be anything, or it could be quartic or quintic, but you see the pattern, it goes on forever. All right, so if I had to come up with this equation, I would need to use my graphing calculator. I don't know the vertex, I don't know the intercepts. We're not going to take the time to put it in, but you got the idea, right, on how to do that. Okay, let's go down here now. The table shows a university's budget in millions of dollars over a 10-year period, where x equals 0 represents the first year in the 10-year period. So at year 0, here's the budget, year 1, 2, 3, 4, etc. Use a graphing calculator to create a scatter plot, which better represents the data, a line, or a parabola. Okay, so go ahead and get your calculator, put all that data in. Okay, and if I were you, if I were taking a test, I'd go through and quickly check my numbers, because it's kind of sad when people put these in and they just, forget a second digit or something. Just checking those. Okay, looks good. So now I've got them in. If I want to see my points, what do I have to do? Turn on the stat plots. Quickest way, go to y equals, go up here, hit enter. They're on. If I just hit graph, I may or may not see those points. I do not. What do I need to do to fix it? Zoom 9 to see my stats. There we go. Does it look linear? And it's not a perfect quadratic, but it's definitely more more quadratic than it is linear. Linear, we wouldn't have that dip. So we're going to go with quadratic, parabola. I would say parabola, and to explain it, I would just say there's a dip, followed by an increase. All right, so we've got that. So where do we go? Stat, where now? Calc, where now? Which one? Number 5, it's a quadratic regression. So we're going to say this. If I wanted to store for me, do you remember where to go? Bars, Y bars, enter. Now it's going to store it for me. And we'll go down to calculate. And there we go. Is it a perfect fit? No, but it's okay, because as long as r squared is above 0.8, we say it's a fairly strong fit. Okay, so let's come up with that. Y equals 1.49. We will always round to the nearest hundredth. There we go. All right, now a little bit tough here. Use the model in Part B to predict when the budget of the university is $500 million. $500 million. Now, look at this. The budget is in millions. So am I looking for 500 million? What number will I be looking for? Just 500, right? How could I do it? Anish? Okay. So you're saying go to y equals and put in 500? Okay, so I'm going to now hit graph. There's my parabola. Not perfect. We knew it wouldn't be. But I'm not seeing y equals 500. Why not? Okay, I can zoom out. I prefer to change my window manually. What am I going to have to make my y max? More than 500. I'm going to make it 550 just to be sure I can see that. So here's my parabola. Uh-oh. What's the problem now? It's going to happen way in the future, isn't it? So I'm going to have to extend my window, my x's. I might even want to go out to 40. I don't know. It seems like it's pretty far down. Oops, I didn't mean to push second. Hold on. Graph. Okay, perfect. So now I can see that. So I do second, trace, calculate, find that point of intersection, get kind of close to it. I don't even see my cursor yet. Where are you, cursor? Oh, I'm too high up. See, look, guys, I'm looking right here. I couldn't see my cursor, but I was going in the wrong direction. I'm trying to get y close to 500. I should be going to the left, not the right. It should show up here shortly. There we go. And then just push enter, enter, enter. And so at 17 years, 17.4 years, to predict when. So what year is it going to be? Well, they didn't tell us what year this represents. So let's say that's the year 2000. What would be the year in which it's going to happen? In 2017, probably in about April of 2017. Do you guys see why? Well, 0.4, actually, I would have to do 0.4 times 12. So it'd be in the 5th month, so it would actually be in May. Around May in year 17. Okay? Questions? All right. Very good, guys. That was a lot.